What if I told you teaching with fractions could be easier? What if I told you there's ways we can use what students have learned in previous years to build on that information, to build on those skills, to build on those prerequisite skills so that we don't have to teach every year as a silo. We don't have to assume students know nothing about fractions. What if I told you that if you know what students learned before, it's going to help both you and the students out to help them understand fractions even more? Well, I'm telling you that. That's my goal right now. My goal today is to take it to the next step. I did a previous video talking about what we learned in first and second and third grade in fractions. If you haven't seen that, check it out. But now we're talking about how about grades 4 and on, moving on from grade 4 to 5 to 6 and seeing how do students learn these fractions and build on knowledge that they've had in the past. So we're going to start with equivalent fractions, and if you saw my last video, you saw that in third grade we learned how to compare fractions using a visual model. In fourth grade, we're going to move from this step that we had here. We're going to move from this very visual way of looking at this. We're going to move to a more algebraic or numeric kind of rule we're looking at with these pieces. And one of the things I want to show us, and again, most adults kind of know how to do this at this point, there's a rule that we have. If I multiply the numerator and denominator by the same value, or n over n if I want to get really fancy, if I multiply it by the same value, it's going to be an equivalent fraction. So 1 times 2 and 2 times 2. A lot of us just know that rule because our teacher said it over and over and over again. Some people know why the rule works, some not as much. But if I look into here, 1/2, I do 1 times 2, 2 times 2, and I go into here, it ends up being 2/4. Now here's the key that we need to kind of look at is we need to use the conceptual understanding students learned in third grade. This was all third grade content. This is not new content for fourth grade, but I do want to remind myself, I want to remind the students what they did learn in third grade so that I can then prepare them to show this rule for fourth grade. And part of the fourth grade standards as we're looking into here is understanding why this works, not just that it does, and understanding how can I explain why this works. And a thing I always challenge students to kind of figure out, and maybe I'll challenge you, is how does the times 2 and times 2 relate to the actual pictures? So I'm looking at this model here and I'm saying, okay, here's this model for 1/2, here's this model for 2/4. Why are we multiplying times 2 times 2? And in this particular case, a lot of us do know this, some maybe not. But when I'm looking at this, I'm multiplying 2 times 2 here. Well, when I did that, there were 2 pieces. Now I've cut it into 4 pieces, so I doubled the amount of pieces I cut. Now, when I double the amount of pieces I cut, each piece is a little bit smaller, as we know. That's something we've been learning actually all the way back to first grade, is the more pieces I cut, the smaller they are because they're all equal shares. So that's going to be the reason here. Now, because they're smaller pieces, I need to have more of the pieces to be equal. So I cut the pieces in half, but now I have twice as many pieces. That's one way I can understand why that works. And again, I can do times 3 times 3, times 5 times 5. I can do all sorts of different rules, but this is a major point we need to understand when we're in fourth grade before we do anything else to understand equivalent fractions. This is going to be extremely helpful when we get to adding fractions that have different denominators and looking at different ideas. In fourth grade, we're going to continue to use those ideas of being able to compare fractions using different strategies, using different equivalent fractions, but we're going to also lean into the idea of benchmark fractions and understanding, hey, how can I compare fractions to a benchmark fraction? So I want to talk about what that means and see how I can compare fractions without even doing a whole lot of work. So if I looked at this and said, okay, let's talk about 1/5 for a minute, and if I wanted to compare that to 7/8, now, I could try and find a common denominator and find equivalent fractions, but that's actually not what we're doing here in fourth grade. In fourth grade, we're comparing them both to a benchmark fraction, and a very common benchmark fraction we're looking at is comparing them both to 1/2. So if I come into here, I can kind of say, okay, so here's my number line, and here is 0, and here is 1, and here is 1/2. And without doing a whole lot of mathematics, I'm going to begin to think about where would these numbers fit on a number line based on what we've learned in the past. Now, they've been using number lines to show where fractions fit on that number line, where they belong on the number line. They used that back last year, so that's not new. The piece that's new is comparing these fractions to benchmark fractions. So if I'm thinking about comparing 1/5 and 7/8, well, if I thought about this 1/5, if I was to divide this up into 5 equal parts, one of those fifths would be somewhere in this ballpark. Now, I don't know exactly where it is, and in fact, I don't even need to be perfect right now, because the intent of talking about benchmark fractions is saying, well, I know that's less than half, because 2.5 is half of 5, or somewhere in that ballpark, somewhere between 2 and 3. And then 7/8 is really close to 1. So I'm looking over here, here's 7/8. So without doing a whole lot of mathematics, without a whole lot of computation, I'm using actually what we learned last year in 3rd grade and building on that and saying, hey, I can see that 1/5 is going to end up being less than 7/8, looking at that benchmark fraction. So that's going to be something we're going to be doing in 4th grade, understanding that benchmark. And so then when we move on in 4th grade, we move from comparing fractions using visual models, using some of our rules, some of our thinking, some of those processes. We're going to talk about adding fractions with like denominators. And we're going to help students to understand, how do I add those fractions with like denominators? I'm going to talk about a few different ways we're going to process that. And I'm going to start off here real simple with like 1/4 plus 1/4. And in fact, they did this already. They did this back in 3rd grade. They added unit fractions together to say that 1/4 plus 1/4. And we're not just jumping to a rule. We're starting with the idea that 1/4 plus 1/4. So here's 1/4 and here's 1/4. And I would always challenge you to say, let's say it 1/4. Let's not say 1/4. Because if I say 1/4 plus 1/4, that can actually be a little bit more confusing to students than it is by saying 1/4. They've actually been talking about 1/4 all the way back to 1st grade. They were introduced to the idea, to the concept of fourths. They weren't introduced to the fraction name of it until last year in 3rd grade, but they've been talking about 1/4 and adding things together and talking about that 4/4 makes one whole all the way back since 1st grade. So it's not new. It's something we need to lean into some of these pieces. So I have 1/4 and 1/4, and I begin to see, well, 1/4 plus 1/4, how many fourths do I have? I simply have 2/4. And that's a way that I can begin to process that idea. And we can begin to move into the concept of, hey, we add the numerators together. We add 1 plus 1, and that equals 2, but we keep the denominator the same. But we really want to lean more into the conceptual idea of, why is it that I'm adding the numerators and why am I not adding the denominators? And in case you don't know, we're adding the numerators because the numerator tells me how many pieces. I have 1 piece and 1 piece. I'm adding them together. I have 2 pieces. The denominator tells us the size of the piece. So 1/4, 1/4. I'm not changing the size of the piece. I happen to have 2/4. This is why I always recommend to say, hey, let's call it fourths as opposed to saying 1/4. It's a little bit easier for folks to kind of look at. So another scenario as we're looking at this, we get a little bit more complex. 3/5 plus 1/5 equals how much? Thinking about that. So 3/5 plus 1/5. So again, I can pull out my fraction tiles and say, okay, well, here's 1/5. Here's 2/5, here's 3/5, plus 1 more fifth. I look over to here, here's plus 1 more fifth, so there's 3/5. 1, 2, 3, plus 1 more. How many fifths do I have altogether? So now I see, okay, there's actually going to be 4/5. And again, I'm building the procedural knowledge of with using the conceptual knowledge. So here I've got that 3 plus 1. I am adding the numerators. 3 plus 1 is 4. And I'm not adding the denominators. And I'm always going to ask students, why am I adding the numerators? Because I literally have 1, 2, 3 parts of that. 3 unit fractions of looking at this. We talked about unit fractions back in 3rd grade. So these are things we did. We talked about 3/5 consists of 1/5, 1/5, 1/5. We wrote that in a number line. But now I've got 3/5 plus 1 more fifth equals 4/5. And that's a very conceptual way of understanding what's actually happening versus just, hey, memorize this rule and then memorize 20 more rules about fractions. We really want to build that conceptual understanding and take our time so students have that depth of knowledge. And then from adding fractions with like denominators, we move right into subtracting fractions with like denominators. So coming into here, I can say, hey, what if I've got 5/6 minus 2/6? Again, we're looking at that and looking at that conceptual idea. I'll push this up. We can see a little better here. So now I've got 5/6. So here's a 6. I'm looking at this. 1/6, 2/6, 3/6, 4/6. Let's see, now I've got 5/6. Great, here we go. So now I've got 5/6 looking through here. And when I'm taking 5/6, I'm thinking about, okay, what if I removed 2/6? I subtracted 2/6. I'm literally taking away. And how many do I have left? If I take 5/6, take away 2/6, 5/6 minus 2/6, I end up with 3/6. And again, I'm looking at that conceptual idea of when I'm looking, what's happening here is I'm literally taking away 2 pieces that are each a 6 large, looking at this. So 5 minus 2 is 3, looking at this piece. And I can also go a little step further. We've been talking about equivalent fractions and talk about 3/6 could also be named 1/2, and I can show this visual idea here. But if you've noticed, what I'm trying to do as much as possible, I'm trying to actually show tiles, show visuals, so we can really connect the idea of what's happening versus just what's the rule. I'm not making up fancy songs. I'm not making up all sorts of different riddles and rhymes we need to learn. We're really building that conceptual understanding, because this conceptual understanding is going to be very, very important as we get to future grades. And then there is one last thing we're doing in grade 4. In grade 4, we're talking about multiplying fractions, but don't worry, we're talking about simple multiplication of fractions as we're doing this. The simple multiplication of fractions is we're going to be taking fractions times whole numbers, looking at these pieces. So fractions times whole numbers, and I'm just going to show an example of what this can look like. So I'm going to go back to, let's see, 1/6. Oops, that's 1/3. So I guess we're going with 1/3. I'm going to say 1/3 times 4. And what does 1/3 times 4 mean? Well, 1/3 times 4, when I come in here, looks like this. So here's 1/3. And what would that look like times 4? Well, if I have 1/3 times 4, what that actually means is I have 4 of them. Here's 1/3, 1/3, 1/3, and 1/3 more. So I'm going to come over here. So really, I'm going to kind of get these out of here. What does that actually mean? Well, if I bring back I like to always kind of show this too. This means I have 4/3. 1/3 times 1/3 times 1/3 plus 1/3 plus 1/3 plus 1/3 really equals 4/3. So that is a valid way to explain this, looking at this idea. So this 4/3, what we like to say, this is a fraction greater than 1. It's more than 1. We used to say it's an improper fraction, and that's not really wrong to say anymore, but we found it was misleading for students to say an improper fraction because they're telling us that's wrong. When we get to higher level math and more advanced math, there's nothing at all wrong about 4/3, nothing improper about it. So we like to say fractions greater than 1. And fractions greater than 1 also give students a better understanding of what's happening. If I wanted to talk about what does this mean, well, this does mean that I've got 1, and how much left? I've got 1 and 1/3 as I look into this. So again, we're beginning to get that idea of multiplying fractions, but multiplying fractions times whole numbers to really begin to say, okay, what does that look like? And we could even just do this idea of, hey, what if I had 2/3 times 2? 2/3 times 2, this is 2/3, that's 2/3, 2/3 times 2 is going to end up being the same idea. So here's just that visual idea of understanding what does it mean to multiply? It means I have more than one of this set. And really leaning into that for grade 4. And that's where we're going to stop for grade 4 with our fraction understanding. And then we're going to move into grade 5 and take a couple next big steps.